Imagine you're in a crowded cafe and you ask Siri to set a reminder. It works perfectly. Now, the person next to you tries the exact same thing. But for them, Siri fails. It stumbles, misinterprets their words, or does not respond at all. The only difference? Their voice sounds different from yours. Their accent is different. Their pitch is higher. Their voice patterns do not fit the data that Siri was trained on. Does someone's gender, accent, or even their race affect how well AI works for them? While shocking, the answer is a resounding yes. For a long time, I thought that software was inherently fair. After all, it's numbers, equations, and statistics. Pure logic, right? But as I delved deeper into machine learning and AI, my perspectives changed entirely. We tend to assume that technology is inherently fair and has no opinions or biases like humans. But the truth is that technologies like AI are trained on real-world data, and that comes with all the imperfections, inequalities, and biases of the real world. And when these models are trained on this imperfect data, they learn the biases and inequalities of the real world. And so when they are applied, they will exhibit these same biases. We can see this clearly in speech recognition models. The 2020 Stanford study that evaluated speech recognition models from 5 major tech companies, Apple, Amazon, Google, IBM, and Microsoft, found that on average, these models had an error rate of 19% for white speakers, but these exact same models had a word error rate of 35% for African American speakers. That is a significant gap and is a great example of bias in AI. Another example is in facial recognition models. A 2018 study analyzed major commercial facial recognition models and found that on average, these models had an error rate of less than 1% for light-skinned men. But these exact same models had an error rate of over 34% for darker-skinned women. That is a massive gap. Their studies showed that facial recognition models consistently performed worse for women compared to men and worse for darker-skinned individuals compared to light-skinned individuals. And this has severe real-world consequences. Today, many modern law enforcement agencies use facial recognitions to identify and pursue suspects. And if these models disproportionately misidentify Black and brown individuals, it will lead to a disproportionate number of incorrect arrests, only exacerbating existing problems. There are real-life examples of this. In 2020, Robert Williams, a Black man in Detroit, was incorrectly arrested for a crime he did not commit. The only evidence the cops had that led to his arrest was recognition by a facial recognition model. That single fact had led to him being arrested. Thankfully, he was found out as innocent, but this is just one example. We also see examples in hiring. Amazon scrapped an AI hiring tool after finding out that it consistently downgraded resumes with terms like Women's Chess Club, but the same model preferred resumes with terms that are traditionally associated with men. One thing to keep in mind here is that gender was not at all an input for this model. Yet, this model had learned through its training data to infer the gender of the subject. Additionally, because it was trained on historical hiring data that contained historical gender biases in hiring, it learned to exhibit these same biases when it was applied. And this is a great example of how bias can unintentionally be included in a model. For me personally, I started to see these patterns more and more as I worked on more machine learning projects. Developers, including myself, tend to focus on how well a model performs on average, how well it performs overall. They often do not consider who it works for and who it fails for. For example, say we have a model that works well for 90% of people. That sounds great, right? But then what if you consider that the 10% of people it fails for belong to historically marginalized groups? That's a problem. For me, the turning point came when working on speech recognition models. While benchmarking speech recognition models, I came across a troubling trend. These models performed far worse for those with speech impediments like stuttering and aphasia. Even when the stutter was incredibly minimal, so minimal that it's hard to notice and that would be easily understandable to any human, these models still performed far worse. And for some people, this led to word error rates of up to 50%, making speech recognition models basically impossible to use. Another example where I have seen bias in AI is in the medical field, where the use of AI is growing rapidly. While working on computational biology projects like a pulmonary embolism diagnosis or an automation of anesthesia, I would read a lot of literature about AI applied to medicine. And when I did this, I found lots of examples of bias in medical AI. For example, a 2020 Stanford study found that a model meant to assess whether a patient needs extra care consistently underestimated the severity of illness of Black patients. Even when they needed care, the model would say that they did not. Once again, similar to the hiring model, race was not an input at all. Yet, this model had learned to infer race, and because it was trained on historical medical data which contained racial biases, it learned to discriminate based on this race. Another example in the medical field is for detecting skin conditions. Studies have found that machine learning models meant to detect skin conditions which are trained mostly on light-skinned data perform far worse for those with darker skin. And for skin conditions like melanoma, where the later it is caught, the worse the patient outcomes, such disparity can have a life or death impact. So, what can we do about this? What can we do to fix this? One of the most effective ways to fight algorithmic bias is algorithmic auditing. Auditing involves rigorously testing machine learning models on diverse data sets before deployment in order to check for examples of bias. For example, the Gender Shades project, which evaluated major facial recognition models, found examples of racial and gender bias in these models, and in doing so, successfully forced major tech companies to change and fix their models. Another key part to fighting bias is in transparency. Corporations must share the demographics of their training data. They must detail the ways their models, and they must explain, and they must justify this, and they must prove fairness. Without transparency, it is impossible to hold AI accountable. And ultimately, we have to get straight to the source. AI cannot be fair if its training data is not. And so this means we have to create the diverse and inclusive data sets. But the truth is that today, modern data sets skew towards English speakers, people from wealthier nations, and those with lighter skin. So what can we do to fix this? We need to include underrepresented voices in the building process of models and data sets. We have to ensure that marginalized groups and activists are involved in building data sets. One example of this is Mozilla's Common Voice project. In this project, they crowdsource audio clips of diverse dialects and accents in order to build more inclusive speech recognition. Ultimately, the fight for fairness in AI is not something that is just for policymakers and developers. It is something that all of us must participate in. What you can do is support ethical AI initiatives. Vote for policymakers and ballot measures that will hold AI systems accountable for bias and that will enforce fairness metrics on AI systems. Also, educate yourselves and others. An informed public is the best way to put pressure and create change in this field and push for fairness. Bias in AI is not always easy to notice. It's hidden by layers of code, masked by complex algorithms, and justified by statistics. But the truth is that we must always think about how just because a decision is made by software does not mean it's fair. Bias in AI is everywhere, and it is not something automatic. It is something we have to fight for. And in doing so, we are not just going to improve AI, but we will also be making the world a better place. Thank you for listening.